Hey, we're going to take a look at the periodic table of elements. You're going to color a periodic table of elements. So to do that, you will need a blank periodic table like the one you see, and you'll either need a set of colored pencils or a set of highlighters to do this. We are going to color with 7 different colors and 1 color that we leave blank. That means that you're going to have 8 different colors, or actually 9 different colors that we're going to take a look at. You'll also need some sort of marking pen to do it, and if you do it in colored pencil, it'll look something like this when you're done. This is the one I made last year with colored pencil. I'm going to do it in highlighter so that you guys can see it a little bit better under the dot cam as I do it. First, let's take a look at this periodic table. It has a key up on the top that reminds you that the number is the atomic number. Remember, that tells you the number of protons and the number of electrons in that most common isotope. Remember, if we change the number of protons, we change elements. So we can never change the protons. It's also going to give you the symbol. For this one, it is capital C, which is carbon. It would either be a capital followed by a lowercase letter or just a single capital. There are a few rare ones that have 3 letters, 1 capital and 2 lowercase. The name of the atom is underneath. We use the American name. A lot of times they're named after original Latin names, and that's why the symbols are different. And then the atomic mass. For carbon, it's 12.01 atomic mass units. And so when we need to find the mass number, we're going to round that to the whole number, and that would be 12 for what we call the most common isotope. If we change the number, it means we changed the number of neutrons and we created a new isotope. Over here, you'll see that we have group numbers. Group numbers go from 1, 2, 3 through 12, and then 13 through 17 and up to 18. This is a change. They used to number groups using numbers and letters, and they've changed it to all numbers all the way over to 18. Periods go from 1 to 7. Starting at the top is 1, down to 7. You'll notice there are 2 rows down at the bottom that don't have any numbers. Those are rows that fit in between. The periodic table would be much, much longer, and these rows would be in there, but in order to print it easily, we shrink that and we just pop these rows down here. So you'll notice that number 57 goes down here to number 58, and number 89 goes down here to 90. Likewise, at the end, 71 goes up to 72, and 103 goes up to 104. Okay, I am going to do most of my coloring in time lapse. If you need to pause, make sure you just pause the video and finish coloring the areas that need to be colored. I will do little discussions in between of what we are coloring. We're going to start by outlining 2 different areas. We're going to outline the metals, and I am going to outline them in red. And then we're going to outline the non-metals, and I'm going to outline them in blue. And you're going to notice that there are some that don't fit in either, and we're going to cover those later. So get your colors ready, and let's outline and make our key down in the bottom. Also, I'm going to put my name. Noble gases are over on the right-hand side. They go from helium down to ununoctium. Ununoctium is just Latin for 118. It just means that it hasn't been named yet. Whoever is able to prove that it's stable gets to name it. So maybe that'll be you. Next, we're going to take a look at the halogens, which are right next to the noble gases. They only need 1 more electron to make that energy level full, and so they are very reactive, but they are not metals. I'm going to color them in green. You can choose whatever color you like, but we're going to color from fluorine down through ununceptium. Now, astatine actually falls in 2 different categories, so I'm going to stripe that one. So those were our halogens. So we're going to label those. And they are not metal, but they are the most reactive. The next category, we're actually just going to leave blank, and so they are just the other non-metals, and they are going to include carbon, nitrogen, oxygen, phosphorus, sulfur, and selenium. And so we're just going to leave those white. They're nonmetals. They just fall in the other category. They're just, a lot of these are just around us all the time. That takes us over to the transition metals. Notice they didn't get put in metals and they didn't get put in nonmetals. They have some of the properties of both, and so we're going to identify them as transition. Now let's take a look at our metals. You'll notice I accidentally put a little line into polonium. I am not going to color that orange. It is not a metalloid. I am instead going to leave it. It's going to fall into the other metals category. So again, I should not have drawn a line around it when I did the red line. It should have been included in the metals. I'm going to start over now on the far left, and I'm going to start with the alkali metals. These are our most reactive metals. They are the ones that have just one electron, and they are anxious to get rid of it. So I'm going to do them in yellow, and down on my bottom key, I'm going to do a box, and I'm going to write alkali metals by it, and then I'm going to write most reactive metals, and then I'm going to color them. You'll notice I did not color hydrogen. Hydrogen is not a metal, it's a gas, and it only has that one electron, and it's anxious to get rid of it, just like everybody else, but it acts very differently, and so we're not going to include it in the alkali metals because it isn't a metal. So now we're going to move over one column over, and we're going to look at the alkali earth metals. They have 2 electrons. They are anxious to not just have 2 out there, so they're going to try and figure out what to do with those, and they're going to be slightly less reactive though than the alkali metals that are one group over. So I'm going to color my alkali earth metals in a light blue, and I'm going to add them down on the bottom. Next, we're going to take care of the transition metals. This is going to be a big chunk in the middle, so choose a color that you like because you're going to color a lot of it. I'm going to use my purple highlighter. When I did this periodic table in colored pencil, I just chose my red colored pencil, and we're going to color everything from scandium down through actinium over all the way over to untrium and, oh actually I lied, copernium, and up to zinc. So we'll follow along as I color those, and then I'll add them to my key at the bottom. You may notice that a lot of the metals that you think of that you know in nature are in here. Nickel, copper, gold, silver, not cadmium. Cadmium is in here, but that's not a metal you probably see all the time. Chromium, like chrome rims, those things all fall in those transition metals. Now we're going to move on to the inner transitional metals, or the rare earth metals. They fall in these 2 categories. They are sometimes broken out separately. For our purposes, we're going to throw them all in one group and call them just inner transitional metals and rare earth metals. So we're going to color everything in these bottom 2 rows in a color of your choosing. I'm going to choose, let's do dark blue. I decided to do them in red, which on this dot cam looks very orange. I also realized while I was doing it that I had neglected to outline that whole block in red because they are actually metals, and so they go down here. Now, that only leaves one small area left for us to color, and that color is just other metals. So other metals are thallium and lead and bismuth and tin and gallium and aluminum, and we are going to color those in, and then we're going to move on, and we'll have all of our groups identified, and then we're going to add some more information. Now you have a completely colored in periodic table with the information you will need to use this year and in your chemistry class, whether you take that next year or the year after. Now we're going to add some more information onto this that hopefully will prove helpful when you're using it. We've already got the periods and the groups labeled. If it helps you to highlight those, go ahead and do that now. Likewise, you have all of your categories down below. Make sure you know where those are and that they're readable to you. Now we're going to add in charges. And we're going to try and think through it in terms of when we did ions, we knew that hydrogen had 1 electron, and therefore when it became an ion, it gave that electron away and it became a 1 positive charge. And beryllium, when we drew out the Bohr diagram, had 4 electrons, but the 2 in the second ring didn't make beryllium happy, and so beryllium wanted to give them away or share them with somebody else, and so beryllium then is 2+. If we knew more about these, we would get into the charges of these, but they require some information on energy levels in shells that we don't have yet. So we're going to leave those and come all the way over to group 13. And group 13 is boron, and they're going to be 3 positive. Everything in that row, if we were able to draw a Bohr diagram for it, would end up with 3 extra electrons in that outside ring that it didn't want, and it would want to give them away. And so when it gives them away, the ion would be 3 positive. And so over here, I'm going to do the little plus minus as ion charge, so that I remember what these numbers mean. Now remember, when you get to carbon, it doesn't really give away or take, it actually just shares. We usually put that on the periodic table as 4+ or minus. Then we're going to look at nitrogen. It's going to have electrons. It's going to want to take in electrons, and when it takes in electrons, it's going to become 3-. Oxygen is going to take in 2 electrons to become 2-, along with sulfur, selenium, tellurium, polonium, and livermorium. Over here in fluorine, it's going to take in 1 electron along with its friends in that group. And then remember the noble gases, they don't react. They have no ions. They have 0 charge, so 0 or no charge, because they don't exist in ion form, because ions, remember, have a different number of protons than electrons, and these guys are stable because they have electrons in their outer shell that match the full shells. Remember, if we want to know how many electrons are in each shell, we're only going to look at the first couple rows. The rules get more complicated, again, because we don't fully understand yet how all of the different energy levels work. When we talk about this in 9th grade, you'll learn more as you go on. But the first level is full with 2 electrons. Remember, in the Bohr structure, there were just the 2 dots. So for helium, there was protons 2, neutrons 2, and then just the 2 electrons. So that one is full at 2. When we moved up to neon, neon had 10 protons, and neon has, that's protons, neon has 10 neutrons, and it has 2 electrons in the first energy level, and 1, 2, 3, 4, 5, 6, 7, 8 in the second. So this means that this energy level can hold 8. When we get down to argon, we start to introduce some of those other energy levels that we don't understand yet, but that's going to make it so that this is going to be stable at 8 or 18. And it gets more complicated as you go. But for our testing and for what we're going to look at this year, we're going to go up through argon. That concludes your periodic table. Take a photo of this, put it in a safe place, make sure that you have it, because you can use this on your Chapter 5 test, your Chapter 6 test, and your Chapter 7 test. So, take good care of it, and we'll see you in the next